What's up, guys? Welcome to another video about circuits and welcome to the show. I know what you did last semester. But anyway, today we are going to discuss some basic terminology about circuits, which is potential difference, current, and how things work in an electrical circuit. So let's jump right into our video, and I will see you at the end of the video. Alright, so this is our basic circuit. This is a battery with its positive and negative terminals this way. Here we have a resistor and here we have a bulb. Alright, now the bulb will obviously light up because we don't have any key. But let us get our terminology right here. Now the current flows always from the positive terminal to the negative terminal in this direction. And the current is denoted by the letter I. Right? And what is current? Current is the rate of flow of charge, right? How fast is this charge moving in this wire? All right. But this is the convention. The convention states that electricity flows from the positive end to the negative terminal. But that is actually not true. What is true is, see, now the electrons are the things which generate electricity in any conductor. So basically we are talking of the movement of electrons, and if we were to talk of the convention, that would mean that the protons are moving from one end to the other, and that is completely wrong and completely out of this world. If you imagine that, the protons would be just too heavy to move. So electrons move from the negative to the positive terminal. But don't confuse yourselves. All textbooks will say that the current flows from positive to negative terminals, and you have to remember that even if the reality is greatly opposite. Now, why does current want to flow from positive to negative? Why does it want to flow? Let us just take an example. Suppose we have two tanks. Like sir told us in school, remember? Two tanks filled with water and they're connected through a pipe. Suppose we have two tanks which are filled with water and they're connected through a pipe, and one is full of water and the other isn't. What is going to happen? The water will flow out through here and empty itself here until the water level of this container comes till here. At this point, both are balanced, right? Both are balanced. And now why did water flow from here? This is obviously a water current. Currents, again, remember, currents will always occur when there is a difference in the level of the two uh, the, the the two things, or what should I call it? In this case, it's a difference between it's a difference between the level of in this case there is a potential difference. Now what is potential difference? Potential difference is essentially how badly do these electrons want to go from the positive to the negative terminal, or how much attraction do they have to this positive terminal. And now because there is a potential difference, the electrons flow. All right. And potential difference, according to our textbook, is a unit positive charge moving from infinity to a given point. Now this is a very confusing definition according to my opinion, but you just have to learn it. I am giving you this for conceptual understanding, that it is essentially that how much attraction do the electrons in the negative terminal have to the positive terminal. That is basically potential difference. Now there is a charge flowing through this, right? Now what is the measure of this charge? Charge is always measured in coulombs, and that's one mouthful of a word right there, coulombs. And coulombs is written like this. Hopefully I've got my spelling right, but coulombs is written like this, and its unit is C, a capital C, mind you. And now what is the unit of current? Because the unit of charge is coulombs and current is the rate of flow of charge. So we need to divide this by time. And what is the unit of time? The unit of time is second. So the unit of current is coulombs per second, or as we call it, amperes. The unit of current is amperes or amps, as some people call it. But the unit of current is amperes, and amperes is nothing but coulombs per second, right? Uh, Now, what is the unit of potential difference? The unit of potential difference is the volt. The battery was made by Volta. He is a scientist. Volta is a scientist, and he made a battery. He invented the battery, and that is why the unit of potential difference has been named after him. How do we calculate potential difference? We find the potential difference by, alright, the potential difference. Oops. Uh, alright, the potential difference, that is V, is found out by dividing the work done by the charge. Now, how does this work? Now, this current is flowing from the positive to the negative terminal. If we go by the convention, and you have to follow the convention, even if it doesn't make sense, but you have to follow it. So the current is flowing from the positive to the negative terminal, right? And it is and the electrons are undergoing some kind of displacement, aren't they are undergoing displacement, so obviously work is done. And before potential difference was discovered, this force was termed as electromotive force, and of course it doesn't exist. It now potential difference is the reason why the work is done. But these electrons are undergoing some work, right? There is a displacement, and that is why there has to be some work. All right, so the work done. Now, work done is measured in joules. If you remember, work done is measured in joules, and the unit is J. So, joules. And now, what is the unit of charge? Unit of charge is coulombs, as I told you earlier. So, joule per coulomb is the unit of potential difference, and that is also known as the volt. That was the end of this video about circuits. Hopefully you understood, and if you did not, drop your doubts in the comment section down below and I will answer them as soon as possible. If you like this channel, don't forget to subscribe, and I will see you in the next circuits video. Peace out.